All right, so I'll just run through very quickly the summary again. So this topic, right, is on light. So in light, we talk about reflection, refraction, as well as dispersal of light, and then lastly about colors. Okay, so these are actually the lesson outline, the objective. So these are the things you need to know. Okay, so last week we ran through this. Okay, but because I think Can you as well as Kieran, they need to look at this because they don't have these notes. They have not seen the slides yet. So these are the main points. So what do you need to do? Explain how reflection is affected, okay, by smooth or rough surface. Then talk about characteristics of image formed by a plane mirror. Okay, describe the effects and uses of reflecting surfaces. Describe effects and consequences of refraction. Describe dispersion of white light by a prism. Okay, and then explain how we see color of objects. Okay, whether it is in white light or is it under colored light. So when we look at them under different lights, we will see different colors of that object. Okay, now compare the speed of light, sound, and common moving objects. That's a very brief one, actually. Okay, we know that light travels the fastest, right? So usually, okay, we see the lightning before we hear the thunder. Okay, now. Okay, so how do we represent light? Usually, we represent light ray with a straight line. Okay, so this is how we represent. Okay, and there is always an arrow. Now, a beam of light will then look like this. Okay, many light rays make up a beam of light, and then they usually move, okay, in straight lines. All right. Speed of light. Okay, 300,000 kilometers per second. Or, okay, if you are talking about meter per second, then it's 3 times 8. Or 3 times 10 to the power 8. Okay. Right? So what I said earlier, you hear it first. Oh, sorry, you see it first before you hear the thunder. Yep, speed of light is faster than speed of sound. Okay, what is reflection? When light hits any surface, okay, we know that there will be reflection. Okay, so incident ray is the ray that comes in. It hits the particular point. Okay, the object here is the book, and then the reflected ray bounces off. Regular refraction, when you have smooth surfaces like mirror, okay, or very still water bodies, you get regular reflection. Okay. If it's a diffuse reflection, okay, this involves rough surfaces. Okay, or water that is not still, not moving. Not still but moving. Maybe there's wave, little bit of wave, etc. Okay, so this is known as diffuse reflection. The light bounces off in all different directions, so they are scattered. Okay, so every light ray that comes in hits the surface and it will bounce off. So image turns out to be blur, okay, or you don't see any image. Now, this is something that I went through with all of you. So you got to try to remember whenever, let's say this is a surface, okay, maybe a mirror, right? When the incident ray comes in, it hits this point, okay, and then it will get reflected away. So how do you find out what is the angle of incidence and what is the angle of reflection? You need to draw a normal. A normal is actually a perpendicular line we draw, okay, based on the surface. So this one is the mirror. If we talk about mirror, okay, drawing this perpendicular line against the mirror, we call this the normal. Don't call this normal line. If you label this as normal line, tell you are going to lose marks. Okay, must be just normal. Draw the normal. Okay, and then incident ray, the arrow, very important. I highlighted to all of you before last lesson. So the incident ray and the normal, okay, forms this angle of incidence. Then the normal as well as the reflected ray forms this angle of reflection. All right. And then they are always the same. Angle of incidence is equal to angle of reflection. Now, so comparing these two, okay, you can see the first diagram shows the very still, very smooth kind of water. The surface is so smooth that you get a regular reflection, very sharp image, very clear. But if the water is moving, so the surface is no longer smooth and still, okay, it is very uneven. So the kind of image that you get will actually look like this, okay, almost nothing. Even if, let's say, you can see something, right, it is very, very blur. So this is called diffused reflection. Now, characteristics of image formed on a mirror, okay? Okay, you have to know all these points. Upright, same size as the object, laterally inverted, okay, meaning left hand looks like right hand, okay, right hand is left hand. Now, take note of the distance also, okay? The distance of the image from the mirror is the same as the distance of the person in front of the mirror, right? Let me just mute my phone. Okay. And then it is a virtual image, it's not real. Okay, it's a virtual image. Now we talk about uses of reflecting surfaces. Convex mirror versus concave mirror. Convex means it is bulging outwards. Okay, so concave mirror, then it is like bulging inwards. There's an arc. So they are used for these purposes. If you have noted those blind spot mirror, right? Okay, this helps the driver to see a large area. Okay, so they can actually see whether there are cars coming or there are any passengers walking or pedestrians walking. Okay, or passengers got out of a certain car and they want to cross the road. Yeah, so those people, they need to watch out for. Okay, now, then this particular dentist mirror is a concave mirror. It serves to enlarge, okay, the image of the teeth and the gum so that the dentist can see the problem there. Now, we look at different types of mirror also, and then we were guessing, right? Okay, which one convex, which one concave? Yeah, so this is the convex mirror. Okay, concave mirror, see how this particular candle is being enlarged. If the candle is at a distance away, it will be inverted. The moment I put the candle closer to the mirror, so I push this thing all the way to the front of the mirror, I see that, okay, now the image is no longer inverted, it's upright, but it is very large. So that's how your tooth, your teeth, your gum is being enlarged by the dentist mirror. Okay, some mirrors are, I think you probably know they sell mirrors. One side, it is the normal kind of mirror, plain mirror. The other side seems to enlarge your face, okay, a lot. There are mirrors like that. Okay, so now you understand how they actually make use of the different types of curved mirrors to achieve that. Okay, so that you can see your face very clearly, whether you have any blackheads, whether you have any pimple, then you can see clearly right now. Oops, what's this? Oh, I haven't removed this part. Okay, now, so at a glance, okay, you compare the type of mirror, all right, and then the properties of the image form, okay, and that uses of such mirrors, this will be useful, okay. So we talk about refraction of light. If you put a straw into a glass of water, okay, the straw appears to be bent. Why? Because, okay, the light ray actually bend and then cause this effect called refraction. Okay, so when a beam of light is sent from water into air, this is the example. Okay, it does not travel in a straight line anymore. It bends away from the normal. Okay, it doesn't travel in the same straight line. By right, it should travel in this line, right? But then because of the different density of the medium, okay, the light ray bends away. So if I were to illustrate with another example, how light rays actually move, okay? So one way is by reflection. So when the light ray comes in from the bottom here, you have reflection, right? Because it hits the glass here, okay? It gets bounced off. Okay, another way light can travel, it happens together. It happens together. Okay, this light ray comes in, hits this point. Okay, as it enters the glass, the speed of the light is affected. It doesn't travel the same speed anymore. It slows down because glass is denser than air. So it slows down. That's why it travels at this angle, still in a straight line, but it's new straight line. When it hits this point and comes out of the glass, it will travel, okay, in the same speed in air, just like before. Okay, that's why this line and this line I circle, right? They are parallel. Okay, they are parallel. This is what your teacher will check for if you are drawing the light rays. Okay, this is what they will check for. So how do you define refraction? This is how you define this. You have this question inside your worksheet, yes or no? Did you answer the question? Okay, this is the very last one, I believe. Let me take a look. It is actually the last second question. Last second question, 13, right? Question 13, you are being asked to define, right? Refraction. So refraction is actually answered this way. Refraction is the bending of light when light passes between materials of different optical density. Okay, so this is the normal. When the ray comes in from the air and then enters the glass, okay, the speed of light then slows down. Okay, and this is the refracted ray. This is the angle of refraction. This is the angle of incidence. They are not the same. The angle of incidence is larger. Angle of refraction is smaller. Okay, must know this. Right, when it is traveling from water into air, look at how it is traveling. So this is the incident ray now, because it comes in here, hits this point, the boundary, and then it comes into the air, right? It will travel at a faster speed. Once it's a faster speed, it will bend away from the normal, right? So angle of incidence here is smaller. Angle of refraction is larger, depending on which medium it is traveling from and which medium it is entering into. All right, so it's found in everyday life. Then we talk about if the image is here, right? Now, you would have come across terms like this. Okay, let me see whether it's here or not. Okay, parent image. Okay, now let me see which question this is. I think you have one question here. If you are not sure of this term, all right, actually image will be sufficient, but sometimes they call it apparent image. They call it apparent. Okay, here is the question position.